Hi guys, so today we're going to be learning how to classify triangles and we're going to be reviewing the triangle sum theorem, the triangle exterior angle theorem, the isosceles triangle theorem, and theorems for equilateral triangles. So first we're going to start by classifying triangles. There are two ways to classify triangles. We can either classify them by their sides or by their angles. So the first type is our scalene triangle, and that is when we have no congruent sides. And what that means is that each side of my triangle is some other type of measurement. So like this is like our shortest one, right? This is a different length from this one, which is my medium length one, which is a different length from this one here. And so since all the sides are a different length, that is a scalene triangle. Okay? The second name is for an isosceles triangle, and that is when we have two congruent sides. Okay? So here, this is an isosceles triangle because this side and this side are the same. We know that because they are indicated by this tick mark here. And then our third type is our equilateral triangle, and this is when we have three congruent sides. Okay? That is when all of the sides are the same length. And here we know that because each of them have that 2 tick mark. Okay? The other way we classify triangles is by angles. Okay? So the first type is our acute triangle. And that is when all of the angles are less than 90 degrees. All 3 of them have to be less than 90 degrees. Okay. It is considered a right triangle when we have exactly one right angle. Okay. The other 2 are going to be less than 90 degrees, so that way they add up to 180. But as long as it has one right angle, it is considered a right triangle. And then here we have an obtuse triangle, and it is considered obtuse as long as it has one obtuse angle. So that's shown right here. The other 2 have to be acute in order to add up to 180. Okay. Then we have our third type. This is our last type. This is an equiangular triangle. This is when we have 3 congruent angles. Okay. In this case, all of the angles are 60 degrees. Okay. And what we know, we'll see that later, but all equilateral triangles are considered equiangular, and all equiangular triangles are equilateral. Okay. An equiangular triangle is a special type of acute triangle. Okay, so here we're going to start with our triangle sum theorem. Okay, so we've seen this before. The triangle sum theorem tells us that our interior angles, the sum of our interior angles of a triangle, is 180 degrees. Right? And so we see that here, angle A plus angle B plus angle C equals 180 degrees. Okay. The next one here is our triangle exterior angle theorem. Okay. And what that tells us is that our exterior angle of a triangle equals the sum of the measure of the non-adjacent interior angles. Right? So an example here is that angle 1 right here equals angle A plus angle B. So this angle here is the other 2 put together. Okay. And then next we have our isosceles triangle theorem and the converse of it. So first I'm going to draw my isosceles triangle. Okay. What the isosceles triangle theorem tells us is that if 2 sides of my triangle are congruent, so here and here, what we know is that the angles opposite them also have to be congruent. So this is opposite, so that would make this angle and this angle congruent. The converse is the opposite. What we know first, instead of the sides being congruent, is that we know two angles of the triangle are congruent. So example, here and here. What that tells us then is that the angles opposite, the sides opposite have to be congruent. Okay. So the difference between the isosceles triangle theorem and the converse, this one starts with congruent sides. This converse starts with congruent angles. Okay. And then the last one here is our equilateral triangle. If it's equilateral, it is equiangular, okay, because all the angles across from them will be equal as well. Okay. So let's get started with some example problems and see how it works. Okay. So here, first we're going to classify it by let's classify it by our sides. So here I see two tick marks, okay, which means this side is congruent to this side, which means that this is an isosceles triangle. Okay. Then I see that it has a right angle. Okay. And as long as it has one right angle, it doesn't matter what the other ones are, this makes it a right triangle. So this is a right isosceles triangle. So the right part is based on the angle, classifying it by the angle. The isosceles is classifying it by the side. Looking at the next one here, I see that I have three congruent sides, which makes it an equilateral triangle. Okay. And then because it is equilateral, it is also considered equiangular. Okay. And equiangular triangles are also acute triangles. However, not all acute triangles are considered equiangular. Okay. So because it is equilateral, meaning the sides are the same, that makes the angles the same. So it makes this angle across, and this angle across all congruent, which makes it equiangular. And if it's equiangular, it has to be acute because each of these are going to be 60 degrees. Here's the next one. So I see that none of the sides are the same. There is no marking. So this would make it a scalene triangle, because none of them are the same. And then I see that I have this obtuse angle. And as long as it has one obtuse angle, it is considered an obtuse triangle. The other two would be acute. So as long as it has one obtuse angle, it is considered an obtuse triangle. Okay, so now let's try our triangle sum theorem. So the triangle sum theorem tells us that it adds up to 180 degrees. So what that means is that for this triangle, 2x, this angle here, plus this angle here, x, plus this angle here, this is the right angle symbol, so that's 90, it equals 180. Okay. 2x plus x is 3x. If I subtract 90 on both sides, this gives me 3x equals 90. And if I divide by 3 on both sides, that means x equals 30. Right? Then, if I plug it back in, that would make 2 times 30. This would be 60 degrees. And then this would be 30 degrees. So let's try the next one here. So again, I have a triangle. It should add up to 180. So 2x plus this one here is x minus 6 plus this one here is 90 should total to be 180. 2x plus x is 3x. Negative 6 plus 90 is 84. 180 minus 84 gives me 96. And then when I divide by 3, x equals 32. When I plug it back in, 2 times 32, this would be 64 degrees. And then since this is 32, 32 minus 6 is 26. It's 26 degrees. Okay. And one way to check your work is that if you add them all up, it should equal 180. Okay. So that's the triangle sum theorem. We've seen it before. Okay. Here we have our triangle exterior angle theorem. Okay. And what the triangle exterior angle theorem tells us is that our exterior angle equals the two interior angles, the other two, added together. Okay, so what that means here is this 2x minus 5 equals x plus 70. Okay. So it means that the one on the outside equals the 2 on the inside added together. So x plus 70. Okay. Then I just need to solve. So subtract x on both sides. I get x minus 5 equals 70. Add 5 on both sides. I get x equals 75. So that means this here is 75, which when I plug it into this one in the orange, 2 times 75 is 150. 150 minus 5 is 145. Okay. And same thing here. This one asked me to find measure of angle 1. Okay. So here, again, the one on the outside, this 5x minus 10, equals the other two. So it equals 3x plus 40. Then I'm going to solve for x, so subtract 3x on both sides. This is 2x minus 10 equals 40. Add 10 on both sides. This is 2x equals 50 divided by 2, x equals 25. Right. If I plug it in, then this would be 75 degrees. 3 times 25 is 75. This one here, 5 times 25 is 125. 125 minus 10 is 115. And then to get angle 1, since angle 1 and this 115 are linear pairs, 180 minus 115 will give me this 65 here. Okay? And so that is the triangle exterior angle theorem. So now we're going to apply our isosceles and our equilateral theorems. Okay. So first one here, it tells me that AE is congruent to DE. So AE is here, and DE is here. So that would mean the angles across from them would be congruent. So opposite this would be right here, it'd be angle D. And then across from this one, right here, would be angle A. So this would make angle A congruent to angle D. Okay. The next one here, we have AB is congruent to EB. Okay. So that's here and here. If you can't see it clearly, right, I would rewrite it. Right? So if you can't see, I would rewrite it separately as something like this, right? A, B, E. So AB and EB, okay, that would make the angles across from them congruent. And since it's unclear here what you mean by angle E, I would name it by 3 letters. Okay. So this would be angle AEB. And then the one across here would be angle EAB. The next one here, we're now dealing with angles. So here, angle D is congruent to angle CED. So angle D is here. Angle CED is here. Okay. That would mean the angles, the sides across are congruent. So the sides across here. So across from angle D is CE. And then across from angle CED would be CD. Okay. Again, if it's unclear, I would separate it out so that way you can see it. Because as you can see, it's getting a little bit busy here. Okay. So next is angle EBC. So angle EBC is here. And then angle ECB is here. These two are congruent. That would make the sides opposite to them congruent. Okay, so across from EBC is side EC, and across from angle ECB is side EB. And there you go. Okay, so all it means is opposite congruent sides is congruent angles. Opposite congruent angles is congruent sides. Okay, so here, let's get started. So here, I see that I have 2 congruent angles. What that means is then the sides across from them have to be congruent as well. So across from this angle is this side, across from this angle is this side. So that means 35 has to equal 5x plus 5. Nice and easy then to solve for x. Subtract 5 on both sides. I get 30 equals 5x. Divide by 5 on both sides. I get x equals 6. Or 6 equals x. Okay. The next one here, I have congruent sides. So this side and this side. If I have congruent sides, that means the angles across from them have to be congruent. So this has to be congruent to this, which means that 9x has to equal 72. When I divide by 9 on both sides, I get x equals 8. Okay. Here, I have congruent sides. Okay. So this side is congruent to this side, which means the angles across from each of them have to be congruent, which means that x equals y. We see that they form a triangle, so that means 102 plus x plus y equals 180. Okay. And since x equals y, I can replace this y with another x, because they're supposed to be equal, which means they're the same. Okay. Then when I solve, 102 plus 2x equals 180. Subtract 102. 2x equals 78. Divide by 2. X equals 36, which means y equals 36. Okay. Sorry, that did not work. Okay, sorry. 180 minus 102 is 78. 78 divided by 2 is 39. My bad. 39. Oop. Okay, which means if x is 39, that means y is 39, right? And so how I knew I was wrong was because I checked my work, right? It should total 180. So I plugged it back in and made sure it works. So 1 and 2 plus 39 plus 39 does give me that 180. So here, x equals 39, y equals 39. Okay, last couple ones here. Okay, so here I have congruent sides again. This side is congruent to this side, which means the angles across from them have to be congruent, which means that x plus 7 has to equal 55. When I subtract the 7, that means x equals 48. Okay. However, this angle, though, 48 plus 7, that means this is 55, right? So x is 48, but the whole angle here is 55. Okay. It's a triangle, so it should total to be 180. So 55 plus 55 plus the y on top should equal 180. 55 plus 55 is 110. When I subtract that 110, y equals 70 degrees. Okay. Last one for today. I don't know if you can see this, but this is a right angle. This is 90 degrees. Kind of faded. I see that this and this are equal, okay, which means the angles across from them are equal, which means x equals 9y. Okay. Because it's a triangle, x plus 9y plus that 90 degrees should total 180. And since x and 9y are the same, I can replace that 9y with x, which means 2x plus 90 equals 180, which means 2x equals 90, which means x equals 45. And if x is 45, that means 45, which is my x, equals 9y, which means y equals 5. Okay. And that's it for today. I know that was a lot. Hopefully a lot of it was review. It's mostly algebra more than it is geometry. But that's it for today. Have a great rest of the day. Bye, guys.